Luke Seibold here, and you're watching Physics X. Today, we're going to be looking at the equations of uniform motion. A lot of the time, you won't be given all the variables that you will need to determine a specific quantity that you may want. You might not always be given a quantity of time, or the displacement that something travels, or its velocity, or its acceleration. And so we have to come up with a couple different equations to determine what these quantities may be. And these are called the equations of uniform motion. So the variables that we have to determine these equations are initial velocity, final velocity, displacement, acceleration, and time. And so the symbols that we have for these: initial velocity is given by U, final velocity is given by V, displacement S, acceleration is A, and time is T. And so I like to remember these as UVSAT. So whenever you see a problem to do with uniform motion, just remember UVSAT and just quickly write these down and figure out the different terms that you have. So the cool thing about these variables is that we only ever need 3 of them to determine one of their quantities. So let's say we're trying to find out what the final velocity of something is. And we only have the initial velocity, we have the acceleration, and we have the time. We don't have displacement, but that's okay. We're still going to be able to find out what velocity is. So as we know, velocity is equal to acceleration times time. That comes from our previous equation that said that acceleration is velocity over time. And so using that, you can switch the variables around and you get this. But let's say that you had an initial velocity that wasn't 0. This is assuming that the initial velocity is 0. So the only thing you need to add is a u, because the acceleration over time will just be added on to whatever that initial velocity is. So we come out with an equation that v equals u plus at. Now, we don't even need the variable for displacement, and using just the initial velocity, the acceleration, and the time, we can figure out what the v is. Now, for our next equation, let's imagine that we're trying to find out what the displacement is. And we have the initial velocity, we have the final velocity. We don't have an acceleration, but we do have a time, and that's okay because we're still going to be able to just use these 3 variables to figure out what s is. So from our previous equation, we saw that s is equal, displacement is equal to velocity times time. And again, this came from the equation that velocity is equal to displacement over time. Rearrange those around and you can get this. Now, again, we have to consider if the object or the thing in motion had an initial velocity. If this is the case, then we have to take an average between the initial velocity and the final velocity. So that will give you s equals v plus u over 2. That's the average velocity between the final velocity, the initial velocity, and multiply that by time. And that gives you your second equation. So if you just have s, v, u, and t, then you can figure out what any of those variables are with just knowing those 4 variables, or even just knowing 3 of those variables, you'll be able to figure out what the 4th is with some simple algebra. Alright, now the cool thing about these 2 equations is that they can be used to derive equations for finding variables when you have any one of these variables missing. So let's say, for example, that we had t missing. Now first we're going to take the first variable, s, displacement equals final velocity plus initial velocity over 2 times time, and we're gonna we're gonna solve for time so that we're able to sub it into another equation and cancel out, so we won't need it. So that'll give us t equals 2s over v plus u. Now what we're going to do is take that equation and sub it in to our old friend up here, velocity equals initial velocity plus acceleration times time. So that's going to give us a new equation where velocity is equal to u plus acceleration times 2s over v plus u. So that's going to give us v is equal to u plus 2as over v plus u. Now we got two v's and two u's in there, so we're going to want to get rid of those. So to do that, we're going to multiply all the terms by v plus u first of all. So that will make this v squared plus uv, and multiply this by v plus u, which gives you uv plus u squared, and then this multiplied by v plus u is just 2as. And now we see that there's a uv on both sides, so we can subtract uv from both sides, and we're given the equation v squared equals u squared plus 2as. So now if we have velocity, if we have initial velocity, if we have acceleration, and if we have displacement, and we're missing time, we can still solve for any one of these variables. Sorry, if we have only just 3 of these variables, we'll be able to solve for whichever the missing one is. Alright, now let's take a look at what to do when you don't have a final velocity. So when you don't have the variable you're looking for, the first thing you're going to do is isolate that variable, and we've already done that over here with v equals u plus at. So let's write that out over here. V equals u plus at. And then we're going to just quickly sub that into our other equation over here. S is equal to the average of final and initial velocity times time. And so by doing that, we get S is equal to, we take this instead of V, S is equal to U plus AT plus U over 2, and that U comes from up there, and the 2 obviously, and then multiply that all by time. So we see there's 2 u's there, so S is equal to 2u over 2 plus 1/2, because that's over 2 times AT, all multiplied by t. And so then you just multiply t by both terms, and you get S is equal to, oh, and we can also cancel out these 2's, S is equal to ut plus 1 over 2 at squared. And that is the equation that we're going to use if we do not have a final velocity and we're looking for any one of these 4 variables between displacement, initial velocity, time, acceleration. If we have the other 3, then we'll be able to find out what any of these variables are. Now I'm going to leave you guys the task of figuring out an equation that does not involve u. So if you go back through some of the examples that we did, just remember that you first isolate the variable u. I suggest using this equation to do that, and then substituting whatever you got for u into the other equation. Then you should be able to manipulate the variables to come out with an equation that does not involve u, that you can use any 3 of the other 4 variables to discover what the 4th variable is. And I'll give you a hint, it actually looks a lot like this equation. So using the equations we've just learned, we can use any 3 of these variables to discover the quantity that we're looking for.